going to review how to graph the cosecant of x. So students that are present with me, they have out this unit circle, and I asked them to go to the points at 0, 90, 180, 270, and 360 and put a 1 underneath each of the values for sine and for cosine, and hopefully that will help us. All right, so the first thing we're going to figure out is we're going to figure out what is the period length for this. So I want to take 2 pi and divide by whatever is directly in front of x, and the number in front is a 1. So I'm going to take 2 pi and I'm going to divide by 1. That tells me that the period length is simply 2 pi. The period length is simply 2 pi. So if you guys could all do me a favor, knowing that we have 4 steps, I'm going to go 1, 2, 3, 4, put 2 pi down. That will be 1 cycle, 1, 2, 3, 4, and I'm going to double this to get 4 pi. Way over here is going to be a cycle to the left, ending in negative 2 pi. The x scale, just like the x scale for the primary trig functions of sine, cosine, tangent, and the secondary trig functions, cosecant, secant, and cotangent that we're working with today, they will all do the exact same thing, have 4 steps. So once I figure out what is this period length or the length of one cycle, I'm going to divide it by 4. So if I take 2 pi and I divide it by 4, it's going to reduce to 1 pi over 2. So this is 1 pi over 2. And remember, there's a couple quick ways to do this, but this is one way. So one quick way to do this is to know that my first step ends on 90 degrees. So first step is 1 pi over 2. So I'm going to continue that pattern. So if this is step 1, then step 2 ends at pi, step 3 ends at 3 pi over 2, step 4 ends at 2 pi. So let's put those measurements in. Now, how do I go about figuring out? These are going to help me relate to what's the input. So every step is the input, but what's the output? The output tells me where do I actually graph at that particular point. Is it on the x-axis, it is above or below, and how far? So let's start with 0. Let's say this is our initial. So when I plug in 0, I'm relating this back to sine. So I'm going to go to 0. So let's go to 0. This is 0 pi, and I want to know what is the sine. Now, as a reminder, it's cosine, and then it's sine. And I'm looking for sine because it's the reciprocal of cosine. So what is the sine at 0? The sine at 0 is 0 over 1. But I don't want to know the sine, I want to know the reciprocal. That's what cosecant is. So the reciprocal of 0 over 1 is 1 over 0. So when I first plug in 0, if I make a little table here, when I plug in 0, I end up with 1 over 0. What does 1 over 0 equate to when we think about it as a graph? What's 1 over 0? It is what? Undefined. It's undefined. So I'm going to go right now to 0, and my output is undefined for the cosecant of x. My next input value will be 1 pi over 2. 1 pi over 2. Okay, so let's go to 1 pi over 2. Here's 1 pi over 2. It's 1 over 1. But I don't want the sine. I want the reciprocal of the sine. So if I take 1 over 1 and I take the reciprocal, which just means I flip. The top goes to the bottom, the bottom goes to the top, I still get 1. I still get 1. So I'm going to come over here. When my input is pi over 2, my output is 1. I'm now going to input in pi, okay? Notice I'm going in 90-degree increments, and now I'm going over to pi. The sine at pi is 0 over 1. Now, 0 over 1, when I take that and take the reciprocal to achieve cosecant, again, I get something that is undefined. So I'm going to go to pi, and that's going to be undefined. 3 pi over 2, I have 2 steps left. I'm on my 3rd step. 3 pi over 2, so I come to 3 pi over 2. The sine is negative 1 over 1. When I take the reciprocal, I get 1 over negative 1, which just equates to negative 1. So I'm at negative 1 at step 3. I'm at negative 1 at step number 3. Let's do one more step, and then we can simply follow a pattern. So at 2 pi, what's happening at 2 pi? So I've done one revolution around the unit circle. I'm looking at the sign. Instead of it being 0 over 1, I want the reciprocal for cosecant, which is 1 over 0. That is undefined, so I'm coming over here. And now, if we went ahead, and I want to demonstrate, if we went ahead, just so you have a better idea of this, can you go on to your unit circle and put your finger right now at 1 pi over 2 and put your finger at 0. Do that for me right now. And if I said moving at the same speed, I want you to take your fingers and start going along the unit circle until they meet. Where would they meet? Turn to your group leader. Where would they meet? They'd meet right here. Do you guys agree? This is directly in the middle. So I'm only going to demonstrate this so you have a better idea. If you had no idea, you'd never watch the videos, this is what I'm going to do. I know that these particular points are directly in between 0 and pi over 2. So this is directly in between these two, and this is directly in between these two. So let me help you real quick. Exact same concept. So if I want to know what is the sign, it's radical 2 over 2. But the cosecant, grab your calculator with me, please. The cosecant is not radical 2 over 2, it's 2 divided by radical 2. So that's going to tell me that output value for pi over 4. The output value for pi over 4 is 1.4. So let's come back to this graph. Here's 1, here's 2, 1.4 is about right here. And if we did the exact same thing, I don't need to do it because watch. This is the sign for pi over 4. This is the same value for the sign of 3 pi over 4, which is directly in between steps 1 and 2. I also would get this value of an output of about approximately 1.4. Remember, as you go closer and closer to the vertical asymptotes, it's never going to intersect or touch. It's just going to get closer and closer as it moves to the left and to the right. Let me press pause. To not waste time, what I would have instructed us to do is the exact same thing. I would say, okay, what's directly in between, as we first start looking at these, what's directly in between pi and 3 pi over 2, and we're going to save some time right now, but you'd go, oh, it's 5 pi over 4. Now, what's the sign? It's the same value that we just did. Remember, we got a reciprocal of approximately 1.4 and 1.4, but this would be a negative 1.4, just like this would be a negative 1.4 for the reciprocal. And that's how I come down here to get a picture that looks like this. Now, my question for you is, how do I use these 4 steps then to graph the next cycle to the right and the cycle to the left? How can I do it without taking time to go and plug in 5 pi over 2, and what do I get for the output graph, and then plug in 3 pi? How can I do this? I'm going to press pause. You're talking as a team right now. You don't have to finish the second cycle to the right or the cycle to the left to save time, but I want you to discuss it to me. It's all based on patterns. So if I'm here and I know that it's a 4-step, I'm going to go back 4 steps. 1, 2, 3, 4. What's the output? 1. I'm going up 1. Okay, I'm going to go back 4 steps. 1, 2, 3, 4. What's the output? The output is undefined. I'm going to go back 4 steps. 1, 2, 3, 4. The output is negative 1. Go back 4 steps. 1, 2, 3, 4. Oh, the output is undefined. And that's how we can see how this pattern in periodic functions is continuous. Every 4 steps is going to be the same, whether I go to the left or I move to the right.